3.4 Combining Transformations and Functions Part 1. Okay, so we have this formula that we can use right here. And we've gone through each of those transformations in previous lessons. So K moves it up and down, H moves it left and right, A is your vertical stretch or compression, and B is your horizontal stretch and compression by a factor of 1 over B. And what this can be utilized to do is to change this point. So if we start with x, y, it can be changed to x over b plus h and a times y plus k. Okay, so let's describe all the transformations in the following. Y minus 6 equals f for x plus 2. So first of all, our a value is 1. Our b value is 4. Our h value is negative 2. And our k value is 6. So we have a, b, h, and k. Now we can decide what transformations we have. So we have no vertical stretch. We have a vertical compression by a factor of 1/4. We are going 2 to the left, so we have a horizontal translation. And it's 2 left. And we have a vertical translation. And it is 6 up. Okay, so let's change a point. So we have the point 2 and 4. We want to change it to the new graph. So we're going to use x over b plus h and ay plus k. So we're going to go x over 4 plus negative 2, so minus 2. And there is no a but y plus k, so plus 6. So there's our manipulation. So we're going to plug in a 2 for our x value, so we have 2 over 4 subtract 2. And we're going to plug in a 4 for our y value, so we would get negative 1.5 and 10 as our new point. And that's kind of how we're going to do all of our transformations for graphs. You pick your points and then plug it into the manipulated point equation. So we're going to sketch and do all of this for the following function. So first of all, domain and range. So it looks like it's going from negative 5 to 4. For our x values and for our range, the lowest point is negative 3 and the highest point is 6. Okay, there's our domain and range. So we have a vertical compression by a factor of 1/3. So that means our a value is 1/3. A translation of 2 units up. So our k value is plus 2. And that's it. So no vertical or horizontal compression or stretch, and no translation. So we're going to go x and y, and then we're going to go x, because x isn't changing, and then our y is going to be y divided by 3, so y over 3 plus 2. Alright, so we're going to pick the points from the first graph, so I want you to pause the video and write out all of those points. So you should have gotten negative 5 and 3, negative 2 and negative 3, 1 and 0, and 4 and 6. Okay, we're going to manipulate them. Our x values aren't going to change. And now we're going to change our y values. So we got 3 divided by 3, which is 1, plus 2, which is 3. Negative 3 divided by 3 is negative 1, plus 2 is positive 1. 0 divided by 3 is 0, plus 2 is 2. And 6 divided by 3 is 2, plus 2 is 4. So here are all of our new points. So we're going to go to negative 5 and positive 3. That point doesn't change. Negative 2 and 1. It's going to go right there. 1 and positive 2, so that's going to go up. And 4 and 4. So our new graph is going to look like that. So domain and range of our new function, domain doesn't change because we did not change our x values. Range is going from our lowest y value, which is 1, to our highest y value, which is 4. Alright, and there's our transformed graph. So let's do a couple more examples of this. So we have y minus 6 is f of 4x plus 2. Our a value is 1. Our b value is 4. Our h value is negative 2. And our k value is 6. I think we did this already on the last page. So our transform points, it's going to start with x and y. And it's going to change to be x over 4, subtract 2, and y plus 6. So as you pause, actually I'll do it with you. So we're going to pick some points. So these ones will help us graph the vertex kind of that point, that local maximum, our intercepts, and then maybe right here. That looks like a good lattice point. So we've got negative 3.5 and 8. We've got negative 2 and 0. We have 0 and 4. 2 and 0. And 3.5 and 8. Okay, before we change our points and graph, let's do domain and range of this function. So this one's going to be element to the real numbers for our domain. And our range is going to be y is greater than or equal to 0 for all the real numbers. Okay, changing our points. So what I want you to do is I want you to pause the video and I want you to manipulate each of these points using this for x and this for y. So you should have gotten negative 2.875 and 14, negative 2.5 and 6, negative 2 and 10, negative 1.5 and 6, and negative 1.125 and 14. And then from here we're just going to plot the points. So we'll go to negative 3.5 or negative 2.875 and 14. So close to 3 and 14. Negative 2.5 and 6, negative 2 and 10, negative 1.5 and 6. The last point is negative 1.25 and 14. So my new graph is going to look like that, except better. my gosh. Alright, better like that. Okay, domain. It can be anything still. Our range, it's going to have to be bigger than or equal to 6. Alright, and there's our transformed graph. Last one, this one has an asymptote, so just know that you can transform asymptotes as well. They won't be stretched, but they will be translated. So first of all, for domain, we have x cannot equal 0. That looks like where the asymptote is. And our range, it looks like y can't equal 0 either. Alright, A, B, H, and K. So we have an A value of 1, there's nothing there. I have a B value of a half. I have an H value of -1 and a K value of -4. So we have X and Y, and we have X is going to be divided by positive 1/2, which means it's 2x minus 1. And our y value isn't being transformed with a stretch or compression, but it is being translated by -4. So let's look at some points here. This looks like a good lattice point. So -2 and 0.5. We also looks like we have 1 and 1. -1 and -1, sorry. And 0.5 and -2. And then we have the same thing on the positive side. So 0.5 and 2, 1 and 1, and 2 and 0.5. We also have our asymptote at x equals 0 and y equals 0. So let's start with transforming those. So our x equals 0 point, again, it's not going to be transformed here, but we are going to subtract 1, so it's now going to be at -1. And our y1 will now be at -4. So I'm going to go in and plot those first. Because that's going to help us graph. So we have 1 at -1 and -4, and I have those backwards. X is -1. Y is -4, my bad. Okay, there we go. Now I want you to pause the video and I want you to fill in this chart for the remaining points being manipulated with this. Okay, these are the points that you should have gotten. Now we can plot. So we have -5 and -4.5. It's right there. We have -3 and -5. And we have -2 and -6. So there is the bottom portion. And then we have 0 and -2, 1 and -3, and 3 and -3.5. So there is our new function. So our domain for our new function, we just have to deal with the changed asymptotes, so -1 instead of 0. And our range is y cannot equal -4. And there you go. That's the end.